Hi guys, it's me Nadiera.
Hi guys, it's me Natasha.
And my name is Nurul Akmar.
So the title of the video is Application of Differentiation and Integration in Car Games.
Okay, so first definition of derivative. The derivative of a function f at a number x denoted by f prime x is, the formula is f prime x equal to limit h approaching to 0 fx plus h minus fx over h if this limit exists. The function f prime x is called the derivative of f with respect to x. So we move on to definition of integration. A function f is called an antiderivative of f on an interval I if f prime x equal to fx for all x in I. Based on theorem, if f is an antiderivative of f on an interval I, then the most general antiderivative of f on I is fx plus c. Okay, next we move on to motion of car. This video shows the movement of car in straight line with different velocity and acceleration in the game that we always play. Let ST be the position of the car. There is the formula on your right. Velocity is the rate of change of the object's position with respect to the time. Next, acceleration. Acceleration is the rate of change of velocity per unit of time. The formula is d divided by dt multiplied vt equal to at. Distance traveled is the total length of the path traveled between two positions. The formula is s equal to vt dt.
Come on guys, let's start.
Oh, wait. Can you see the traffic light was in the red color? It means we need to stop. So here, when the car stopped, the car was in the 0 position and 0 velocity. Okay, now the traffic light turns into the green light. The car starts to moving and experience acceleration. Oh, there was a bar right there. So the car need to brake and then stop. When the car brakes, it produces deceleration, and when the car stops, it causes the car become in 0 position and 0 velocity.
Now we start with the problem statement. Okay, a car moves along a straight line and passes through a fixed point O. Its velocity v meter per second is given by v equal to pt squared minus 60, where p is a constant and t is the time in seconds after passing through O. Acceleration of the car is 18 meters per second squared when t equal to 3 seconds. There are 4 types of questions that we will figure out for today. So let's begin with the question A. Find the value of p. Since the velocity equation is given, therefore, to find the acceleration, we need to differentiate the velocity. So, the velocity equation is v equal to pt squared minus 60. So, when we differentiate, it will become 2pt minus 6. So, the acceleration equation becomes 2pt minus 6. Based on the question, the acceleration of the car given is 80 meters per second squared when t equal to 3 seconds. Therefore, we can substitute t with 3 and equal it to 18 according to the info given. So, when we substitute t with 3, it will become 6p minus 6 equal to 18. Then, we move the 6 to the right hand side and will become 6p equal to 24. Therefore, the answer for this question is p equal to 4. So, we move on to the next question. Find the time interval in seconds when the velocity of the car is decreasing. When the velocity of the car is decreasing, the car will experience deceleration. So as we all know that decelerate occur when a is less than 0, which is it will be negative. So by using the acceleration equation that we find in question A, we will make it less than 0. So the acceleration equation that we got is 8t minus 6 less than 0. So when we move 6 to the right hand side, it will become 8t less than 6. So the answer is t less than 3/4. So the time interval taken when the velocity of the car is decreasing is between 0 and 3/4.
Question C. Find the time in second when the car stopped instantaneously. So as we know, when the car stopped instantaneously, velocity is equals to 0. So it will be pt squared minus 6t equals to 0. As we know, p is equals to 4. So we insert 4 into p. It will be 4t squared minus 6t equals to 0. And then we factorize the equation into 2t in bracket 2t minus 3 equals to 0. So we will split them into 2. So the first one, it will be 2t equals to 0. We bring 2 to the right hand side, it will be t equals to 0. For the second one, 2t minus 3 equals to 0. So as we bring negative 3 to the right hand side, it will be positive 3. So the equation would be 2t equals to 3. And then we bring 2 to the right hand side. So it will be t equals to 3/2. Question D. Find the total distance in meter traveled by the car in the first 3 seconds. So this is a graph of a function of 4t squared minus 60. So we need to find a1 and a2. So firstly, we need to find a1. So we have to integrate the equation v with the upper limit of 3/2 and the lower limit of 0. The next step is we need to substitute the equation. So it will be 4t squared minus 60. The next step is we need to add the power by 1 and divide the equation by the power added. So it will be 40 cubed over 3 minus 60 squared over 2 with the upper limit of 3/2 and the lower limit of 0. Next step is we need to simplify the equation. So it will be 40 cubed over 3 minus 3t squared with the upper limit of 3/2 and the lower limit of 0. The next step is we need to substitute the upper limit into the equation minus with the substitution of lower limit into the equation. So a1 would be 1/4 meter. So next, a2. So we need to integrate the equation v with the upper limit of 3 and the lower limit of 3/2. The next step is we need to substitute the equation. So it will be 4t squared minus 60. The next step is we need to add the power by 1 and divide the equation by the power added. So it will be 40 cubed over 3 minus 60 squared over 2 with the upper limit of 3 and the lower limit of 3/2. So the next step is we need to simplify the equation. So it would be 40 cubed over 3 minus 3t squared with the upper limit of 3 and the lower limit of 3/2. So the next step is we need to substitute the upper limit minus with the substitution of lower limit. So it would be 9 plus 2 1/4. So a2 will be 45/4 meter. So lastly, the total distance travelled by the car, it will be a1 plus a2. So it will be 2 1/4 plus 45/4. It will be 13.5 meter. Lastly, conclusion. As we all know that calculus is very useful in our daily life. For example, in physics, calculus is used in its concepts. Among the physical concepts that use the concepts of calculus are motion, electricity, heat, light, harmonics, acoustics, astronomy, and dynamics. According to this video, the derivative is used to find the acceleration of the car, while integration is used to figure out the distance travelled by the car in the games. As conclusion, the concepts of derivative and integration is applied in everything that we did in our life.